Hey, hi, this is Hemant and my colleague Jayant. Today we are going to explain the brain tumor detection using deep learning. In this project, we are going to use the convolution neural networks. Deep learning is mainly used for the object detection, recognitions, and so on, etc. So, coming to the agenda, today we are going to explain our objective, abstract introduction, what are the softwares we are used, and what are the methodologies we are followed to overcome the result, and what are the performances of different algorithms and their comparisons. So coming to the objective, it provides the good software to identify the tumor and the causes, and it saves patient time, and also it also uh, provides the better solution at early stages. It won't take a long time, and also it will provide a good timely consultation for the patients and as well as doctors. So coming to the object, the main idea of this project is we want to detect the brain tumor of a particular location by using the MRI or CT scan. Normally we know that tumor means it is cells growth in a human brain. So this technique we are going to carry in two steps. First one, it is in converting the grayscale image to the comparing of different tumor images from MRIs or CT scans. Then after that we are using CNN architecture to find the location. So here we are going to study the CNN by using the tumor region of MRI image in terms of pixel intensities by convolution theory networks or backspooling or else flatten the surfaces and so on, etc. By using these components we are going to get the at exact location what are the edges where it is all swollen, and in this project we are going to find the tumor. So introduction, normally we know that it is a abnormal mass of tissue which grows rapidly, and also it also uncontrollable by the mechanisms of normal cells. So basically we know that there are so many types of brain tumors, but here we are going to use only non-cancerous and cancerous cells. Non-cancerous cells is nothing but benign, and cancerous cells is nothing but malignant. So by detecting this tumors, we know that this method also recognize tumors, and it also easily performed by the doctors, nothing but radiologists and clinical experts and labs. So it also depends on doctors experience, one-to-one experience, and so on. So by using this project we can also measure the minimize the error, and also it identifies the tumor in very less time compared to the MRI and CT scan images. So cancerous tumor also it is defined as two tumors, primary tumor and secondary tumor. Primary tumor are which comes from brain tissues, and secondary tumors are nothing but they will spread to the all over the body parts. So this process is called metastasis. So malignant tumor is more harmful than the benign tumor because it also spreads rapidly in irregular shapes and different types of body, and also it grows the extra cells of 50% than the possibility of recovery. So patient time is also optimum, and development is also the medical imaging process. So MRI and CT scan are almost infrequently using the imaging technique in neuroscience or nowadays, or else in so many techniques, so which provides the deep structure of the brain by creating the 3D images, 2D images.
Yeah, now coming to the methodology, firstly, we have collected the images of the tumor. We have the two cases, yes or the no cases, and necessarily we need to have some of the pre-processing steps which we need to complete uh, before we train our algorithm. Once after training the model, will be saved for testing and classifying. And user can upload the images of which to be classified, and by using the saved model the images will be classified and predicted. And this is the data flow diagram for our project. And first case, in the primary phase, we need to take the data set, and then it goes to the pre-processing, then splitting the data, building the model, and classification and prediction of the tumor. And coming to the system, first uh, we need to create a data set. The database contains the image of the brain defect. Images are classified and split into training and testing dataset with the size of 30 to 20 percentage. We're coming to the pre-processing, resizing, and reshaping the images into appropriate format to train our model. And coming to the training, we need to train the we need to train using the preprocessed dataset using CNN algorithm along with some of the transfer learning methods. And coming to the classification, the result of the our model is display of tumor images are either with defect or normal. And coming to the user need to upload the image. User has to upload an image which needs to be classified, and based on it, the classified image results are viewed by the user. And coming to the CNN is an deep learning method used to create image editing. Con Connets has successfully identified faces, object, and diagnetics. The neural convection network consists of convectional layer and pooling layer and fully connected layer, which can perform a different function in the input data. And this is the basic framework of the CNN architecture. Input, and then the input is the image of the brain tumor, like of the some of the samples of the in the data set, and then it goes to the pre-processing phase. The now it goes the no, then it goes to the pooling, and then it gonna be split into the sum of the different cases, and then it gonna move to the flattering. Then this is the last stage of the last layer, which is the fully connected layer.
It is in CNN architecture. The first input is we are going to take the brain tumor image. It will directly goes to the feature maps, nothing but convolution plus ReLU. Uh, in convolution layer, it will take the made up of a set of filters which call kernels that are applied to an input image. The output of this layer will get a feature map which is representation of input image to it will filters the applied image. So it can be stacked to create more complex models or else which can integrates features from the images. From convolution plus ReLU neural networks, it will goes to the pre-processing stage. In between this pre-processing stage, there is a layer which called pooling layer. It is also a one type of a convolution neural network which is used in deep learning. So it also reduces the spatial size of the input, and also it will take a making easier process and requires less memory. And also the parameters makes transferring faster compared to the normally neural networks. Here the max pooling also takes the maximum value from each feature map, and also while average pooling it takes the average value from all over the data sets. From by flattening, it will be going to the fully connected neural network, which are a most basic type of a CNN algorithm. As it name suggests, each neuron in fully connected layer is fully connected to each other, and the layers are typically used towards the end of a neural networks. So our goal is to take the features learned by the previous layers, use them to make predictions. For example, we are using a CNN to classify images of a different animals or else different brain tumors. The final fully connected layer might take the features learned by the previous layers, and it is used to classify an image by containing it is a dog, cat, bird, etc. So it is the convolution layer. It will take the process of removing elements from an image, and also it has the few filters like kernels to make the work. And pooling layer, it is an operation which reduces the size of the maps, and also the input we are going to take here image is 32 cross 32 cross 10, and the pixel size is 16 cross 16 cross 10. And fully connected layers is also an integrated layer which products the previous layer from the pooling and convolution, which is a fully integrated layer. So in this project we are going to use the softwares Python and Jupyter notebook by Anaconda, and it is our results we have taken from the model loss. So our data set is It is in Harvard medical data set from the Harvard University, where they have trained in different models of brain tumors of as image or no image. And finally, we got the brain tumor of a particular location. So in fixed data set, there are different type of brain images. Uh, Nothing but malignant cancerous cells and non-cancerous cells. And also here we have used it in a TensorFlow Keras model. In Keras model, we have installed our packages like activation, dropout, flatten, convolution 2D, and normalization. From convolution 2D, we have known the pixel sizes of the brain tumor images by taking the input by calculating the ReLU network on the convolution neural network. So it is the functional one output which we know that we are taking the image. The image is going to process us to the convolution 2D. From the convolution 2D, it will go to the max pooling 2D to the normalization, and the loop will be run as soon as possible. In this, we are going to train the data set of by splitting the data set into x and y. In x and y, we are going to test the. We are taking 70% for the training and 30% for the testing. Epox is nothing but we are getting the how much of accuracy we are getting the brain tumor images. So if we increase the epoch value, the accuracy will get increases as soon as it gets lost. So here we have taken the epoch value is 80. So we have got the accuracy of 100 by 100 percentage to predict the brain tumor. It is the basic CNN performance of an brain tumor image by taking the accuracy and loss where with an epoch size of 80. And it is an fixed data set and hardware data set, which is in second one. It is also same like an fixed data set, but here we have used an sizes of different by taking the different epoch values and the different accuracy and different loss. So it is the value loss and validation loss by taking the training and testing of 80 percentage and 20 percentage. So it is a program with running code and an output of an accuracy and loss. So it is a result of where the first image shows a tumor of an 100% confidence, and second image shows it's not a tumor. And it is the performance comparison of different algorithms. So first we have taking the traditional machine learning algorithms classifiers. So Navis Bayes we got the specificity of 91 where it accuracy is 77, and random forest algorithm says the accuracy of 88 where KNN algorithm shows the 84 and the SVM classifier shows 88. By when we are comparing the two neural networks, ANN got the 84 percentage of the accuracy, CNN got the 93 percentage of accuracy, and LSTM algorithm shows the only 90% of accuracy when compared to the other algorithm. So we find that the CNN will perfectly suits for this brain tumor detection to identify the exact location of the tumor. So it's the conclusion. So we have studied about what are the features it will be performed, and also what are the techniques here we have used, and the comparison and accuracy of the brain tumor image. And also in future work, if we want to try with the new images, so we can go with the 3D images or 2D images to get an as fast as result. So these are the differences we have followed by taking the from the Google. Thank you.